Okay, this is section 5.1 in the grade 9 textbook on polynomials, Introduction to Polynomials. The first questions in the show you know say for each expression, identify the number of terms. Oh, that's not what I wanted to do. I want to take a black marker. The number of terms and whether the expression is a monomial, binomial, trinomial, or polynomial. Okay. So the first one is number of terms. When we're defining how many terms something has, a term is loosely defined as a part of an expression. This is the easiest kind of identifiable mark. Part of an expression connected by addition or subtraction. So when I look at the first one, there is no addition or subtraction. There's just one 5j squared, which means there is just one type of term in this particular expression. It's just j squared. How many of them? There's 5 of them. So we call A 5j squared. It's a monomial. And the second part is how many terms is it? It's just one term. In B, there is a subtraction symbol here, which means we are connecting to that the 3 and the m squared, which makes 3 minus m squared a binomial because it has two terms. It has the term 3 and a different term of m squared. C, ab squared minus ab plus 1. Well, here we have 3 terms. We have an ab squared, an ab, and a 1, connected together, of course, by those subtraction and addition signs that I told you to look for to help you define how many terms there are. It's a little difficult to say what does an AB look like. It's easy to show you what an x squared looks like, but an AB is not as easy. So here we have AB squared minus AB plus 1 is a trinomial because it has 3 different terms altogether, or 3 terms, or types of terms. And finally, D, there's 1, 2, 3, 4 terms. And generally speaking, because we don't want to call it a quadnomial, we call it a polynomial instead of a quadnomial, okay? So that's the first part, which is pretty darn easy. All you have to do is look for the addition subtraction signs and look to see what it connects together. As we're going to see, sometimes it looks like a trinomial, but 2 of the terms are going to be like terms, as we call them, and can be simplified down to 1 term. So a trinomial might become a binomial depending on the type of terms it has, but we'll worry about that in the next section. Our next show you know says, what is the number of terms and degree of each polynomial? So again, A has one subtraction symbol right here, connecting together the term of 1 and 3x. 1, of course, being your constant, and 3x being a term of x's. So therefore, we would say 1 is a binomial, meaning it has 2 terms. And the degree of each polynomial. So before we call a degree of a polynomial, you have to explain the degree of a term. And the degree of a term is defined by the sum of that term's exponents on its variables. So if we think about the term 3x, up here where we would normally find the exponent on the x, we would see that x actually has an exponent of 1, but it's not written. So in this particular expression, 3x would have a degree of 1 because the term itself has an exponent of 1. If you have a constant like 1, we always say its degree is 0, even though we just learned in the last section that 1 is actually 1 to the exponent of 1, but we're not going to get into that. If it's a constant, we will consider it to have a degree of 0. So therefore, altogether, this has a degree of 0, this has a degree of 1. The whole polynomial has a degree of its highest term only. And since only one of those 2 terms has a degree at all, we call it a degree of 1. Now this is going to make more sense with B. B, we have a trinomial. And the degree of this one is 1. Now the degree of 3xy. Now we've never seen an xy before in our algebra experience. This is your coefficient. The exponent on the x is 1. The exponent on the y is 1. So therefore, 3xy has a degree of 2. And like I said in the last question, if it's a constant, it has a degree of 0. So in this trinomial, the first term has a degree of 1, the second term has a degree of 2, the third term has a degree of 0. So the entire trinomial, we are going to say, has a degree of 2. They might think it's 3, like Cole did, which is understandable because you think 1 plus 2 plus 0 is 3. So obviously the trinomial can have a degree of 3, but that's not the rule. The degree of the polynomial is simply defined by the degree of the highest term within the trinomial or binomial or polynomial. In this case, 3xy is the term that has the highest degree, and therefore the entire trinomial is defined by that one part. C, there are no addition subtraction symbols, which makes this a monomial. And the degree is the sum of the exponents. Since there is only one exponent on that variable 2, it has a degree of 2 as well. And finally, D is a monomial. And since it's just a number, it's just a constant, there is no variable, it means it has a degree, since there is no variable, of 0. And in your last show, it's asking you to model certain things. Now remember, when we model, the introduction that you should have had before is that this here, we call an x squared, and this one here, which open, that's not shaded in, we're going to be something we consider to be a negative x squared, or the opposite of whatever x squared value is. This term here, we're going to define as being x. This one is being a negative x. And this one here, in the book, it uses a square and an open square. Sometimes I'm just going to use integer chips instead, but this is a +1 and a -1. And the reason why we define these as such is because this one here has a length of 1 and a width of 1, and that positive 1 actually represents that chip's area. It has a positive 1 area, and this one, of course, is not going to be a -1 times a -1, because that would be a positive 1 as well. It's just the opposite to the value that 1 would have. Now, since this length here is 1, we also define this length here as being 1, and this length here as being x. So a length of x and a width of 1, or a width of x and a length of 1, gives this an area of this algebra tile, as being a positive x, and this being the opposite of that, or a negative x. And finally, since this length here is x, this length here is x, as well as this. So we know from our experience with exponents that an x times an x is represented by the exponential form of x squared. And this here, therefore, when it's not shaded in, will be negative x squared. So how do I model a negative x squared plus 4x minus 3? Well, the answer would be I need 4 of these. Because, oh no, sorry, not 4 of them, 1 of them. Sorry. That is negative x squared. That's the first term in my drawing. And plus 4x would be 4 of these, not these, but 4 of these, which means that's 1x, that's 2 x's, that's 3 x's, and that's 4 x's. And then minus 3, just like that. So this says negative x squared plus 4x minus 3 using algebra tiles. The second one, what expression is shown, so we're going to reverse it. This is an x squared, so we have just one of them. But we never write coefficients of 1, so we're just going to call it an x squared. This is an x, an x, and an x, which makes it a positive 3x or a plus 3x. We're going to think of it both the same way. And these are all negative 1, so we have 4 negative 1s, or negative 4. So therefore, this picture represents this in terms of a polynomial. It's a trinomial.